Today I'll talk about Java functions and constructors. Related to that, I would like to discuss about function overloading or method overloading as well as constructor overloading. But before going to discuss all those topics, few things we need to revise. Actually, Java is an object-oriented programming language, we know that very well. Before implementation of this kind of programming language, we had traditional procedure-oriented languages like C, Pascal. They had this kind of facility of writing programs using procedural oriented language. Now what happens in that case, actually we may have some global variables. Global variables means the variables which are declared outside the methods or functions. Then we may have several functions in a program, and those functions will access the global variables and they will do their jobs, and we must have a controlling function. All the other functions will be linked to that controlling function. So this way a procedural oriented language works. But what happens in case of Java? As Java is an object oriented programming language, so we may have multiple objects in a program. Actually you can see that here we have some boxes, each of them is an object. Now in each box we may have a box name, we may have some attributes. Attributes means the variables we may declare, and some functions or methods which will access those variables. So in this object we have a specific name, some variables as well as some functions. Similarly, in the same program we may have another object with another name, some other variables and some other functions. This way we may have several objects, and these objects can be linked to each other and they can work together to perform the job of the program. So this kind of concept is called object-oriented programming language. Let's see the details of an object. As we know that in an object there must be a name, some static attributes. Static attributes means some variables inside the object, or you can say some data inside the object, some methods which controls the behavior of the object, because it depends on the method and that what kind of action it is going to perform. For example, we can say here some objects we may have, say one object name is student, another is circle, another is soccer player, another is car. Now in this object the object name is student, and some variables or static attributes we have here. One is name, another is GPA, and some methods we have here which controls the behavior of this object. And say get name is a method, get GPA is another method. Similarly in this object, here the object name is circle, and we may have some variables like radius and color, and two methods we have here. One is get radius, another is get area. So these methods are controlling the behavior of this object circle. Similarly in case of soccer player object, here we may have the name, the number, then the X location and Y location of the player, and then some methods like run, jump, kick ball. All these are the methods of this soccer player object. That means we have some variables as well as some methods. Now the last object here the object name is car, and some variables we have here. One is plate number, another is X location, another is Y location, another is speed. So these are the variables, and some methods we have here. One is move, another is park, another is accelerate. So these are the methods which are controlling the behavior of this object car. Now let's see one example. Say we may have one object, say the object name is student, and we may have some variables in this object. One is the name, another is GPA, as we have seen here. So this student object, it has two variables. One is name, another is GPA, and two methods to control its behavior. One is get name, another is set GPA. So The example of this object we can see here. Say the first object here, the name is Paul, and GPA is 3.5, and in second object here the name is Peter and the GPA is 3.9. That means the same object can represent different values this way. So this is one of the characteristics of object-oriented programming language. Now what happens when we form any object, it takes some space to be stored in computer's memory. So you can see here, say this is an object. We have some public methods or functions, some private data or private methods also we may have. Now this private data and private methods, they are workable inside the object only, they cannot go out. They can be available to the outsiders only through its own public methods. Therefore the private data and private methods, they can interact with the public methods of the same object, and the public methods are accessible outside the object. Therefore through this public method, this private data or private methods can be accessed. For example, if we have some private variables and private methods, directly from outside of the object we cannot access them. So if we have any public method inside the object, then through that public method we can access the private variables and private methods to the outside. So interaction interface can interact only with public methods, and through the public method these private variables or data or private methods can be accessed to the outside. So it's clear to us that each and every object has a model, and that model is called a class, and that model or the class has some properties including variables and methods. Whenever we form any object of a class, then the properties get stored in computer's memory. Therefore forming multiple objects of the same model or class, we can store different values to the variables, and actions can be performed on those variables for different types of jobs. So now let's talk about Java methods. What is a method? A method is a block of code which only runs when it is called. That means a block of code means some of the lines of the codes when we write within curly braces, that is called a block. So a method means it must contain a block of codes. We can pass a data to a method which are known as parameters of that method. Methods are used to perform certain actions, and they are also known as functions. So we know that the class or the model of an object, it must have some behavior, and that behavior is fully controlled by these methods or functions. By constructing a class and forming different objects of that class, the methods of that class can be reused whenever required. That means, say in a class we have some methods, and in another program any similar method is required. So instead of writing the same codes again for the new program, what can we do? We can use the method stored in our previous class. That means reusability of methods is possible in Java. How do we create a method? A method must be declared within a class. Already we know that. It is defined with the name of the method followed by parentheses. Java provides some predefined methods such as system.out.println. We know that whenever we display something on the screen, then this method is used. So we don't define this method, means how it is going to perform its action. Actually Java developers, they developed this method, and that's why this is called predefined method, which is stored in Java library. But we can also create our own methods. One example is given here. You can see we have a class, and class name is my class. So this is the model or class which we are going to form. Then static void my method. Here my method is the method name and its return type is void. Void means this method is not going to return any value. And static, this method is static in nature. And definitely the block of codes whatever we will have, we have to write here between these curly braces. So this way we can construct a method. So already we have got this example. Now let's see the details of the components of this. My method is the method name, already I have mentioned that one. Static means that the method belongs to the my class and not an object of the my class. So what does it mean? We know that whenever we access any class member, it may be a method or it may be a variable, then using the class object we can access that. Formation of a class provides a wrapper which protects the properties of the class. This kind of mechanism is called encapsulation. But when any method is declared with static keyword, it means to access this method, class object is not required. So without using any class object, a static member of the class can be accessed. It may be a variable, it may be a method. Void is a keyword. Already I have explained that it is the return type of a method, and if the return type of a method is void, that means this method is not going to return a value. I hope all these components are clear to you. Let's see how do we call a method. To call a method in Java, what we do, we just write the method name followed by two parentheses and a semicolon. For example, we had a method, my method, and when this method will be called, how do we call it? Let's see. Say inside the class, here class name is my class, we have this static method, my method, and just it is going to display one message. What's the message? I just got executed. So we have declared the end of this static method here. Then we have constructed another static method, that is main method, and here inside this main method what are we doing? We are just calling this my method. So only my method followed by parenthesis semicolon will be used to call this method. So program execution will be started from this, and when it will get a call of this method, program pointer will be shifted to this method, and definitely it is going to display this message on the screen according to the given instruction. So after completion of the execution of this method, program pointer will be returned back to the main method, and this is the end of the main method, so program execution will be over. So what will be the output of this program? Output will be this message what we have displayed, I just got executed. Now what will happen if we call the same method again and again multiple times? Let's see one example. Here the class name is my class, and inside this class we have a static method, my method. It is just going to display one message, I just got executed. Then in the main method 3 times I have called this my method. So when first time it will be called, program pointer will be shifted here, it will display this message. Then the method execution is over, it will go back to the main method. Again it will get a call of this method, so again the program pointer will be shifted here and it will display this message once again. Then after completion of the execution of this method, again program pointer will be shifted back to the main method. Then again it will get a call of this method, so program pointer will be shifted here, and third time it will display this message, and then it will go back to the main method, and this is the end of the main method. So 3 times it is going to display this message on the screen. Now let's talk about method overloading. What is this method overloading? Method overloading is a feature that allows a class to have more than one method having the same name if their argument lists are different. It is similar to constructor overloading in Java that allows a class to have more than one constructor having different argument lists. That means in a class we may have multiple methods, but if the method names are same, then that is called a method overloading. Now the question is, if whatever the methods we are having in a class, if we use the same name for all the methods, then when a particular method will be called, then how compiler will decide which method has been called? So in case of method overloading, what happens? The methods, they share the same name, but they may have a different parameter list, or the sequence of the parameters may be different. So they are having the same name, but list of arguments or parameters or sequence of arguments or parameters may be different. So this way constructor decides that which particular method has been called for this action. Now the question is, if we implement method overloading in a program, what kind of benefit we get? Actually, in case of method overloading, what happens? The overloaded methods, they share some memory space. As a result, memory consumption will be reduced, and definitely space complexity also will be reduced, and program will be more efficient. In this example, you can see that we have two methods. In both the cases we have the same method name. Here also it is add, here also it is add, but in this method we have two integer parameters, and in this method we have three integer parameters. So obviously when we will pass three integer values during method call, then compiler will have no difficulty to understand that this particular method has been called. And when we will pass two integer values for the method call, that time compiler will take this decision to call this method. So this way compiler can differentiate the methods, that which particular method has been called for the action. There are three different ways to overload a method. So in order to overload a method, the argument list of the methods must be differ in either of these. First one is number of parameters. Say here two methods we have, already I have discussed this example. In both the cases the method name is same, but in first method only two integer parameters are there, but in second method three integer parameters are there. So this way they are different from each other. Another way to implement method overloading, here also we have two methods, one is this, another is this. In both the cases the name is same. In case of first method it has two integer parameters, but in case of second method it has one integer parameter and one float type parameter. So whenever this method will be called, definitely we are going to pass one integer value and one fractional value for this method, but in this case both the values will be integers. Third way to implement method overloading is sequence of data type of parameters. Already I have mentioned this one. Let's see the example. Say here also we have two methods. In both the cases the method name is same, but in first method first parameter is integer type, second parameter is of float type. But in second method, first method is of float type and second method is of integer type. So whenever this particular method will be called, we have to pass the value of this parameter. So first value will pass, that is integer, and second value must be a fractional value. Just opposite thing we will have in this case. Here the first parameter will pass a fractional value and second parameter is an integer. Some people think that if the methods are returning different types of values, in that case also we can implement this method overloading, but this is the invalid way of overloading a method. Let's see this example. In this case you can see the first method is going to return one integer value and the second method is going to return one float type value. Both the methods, they have two parameters, both are integers. So this is an invalid way of implementing method overloading. So this way you can't overload a method. Method overloading is an example of static polymorphism. So polymorphism, what is that? You know very well. The characteristics of Java, when we studied that time we got this term polymorphism. Same objects can be represented in different ways, that is called polymorphism. So here we are using the same method in different ways, therefore method overloading is an example of static polymorphism. Let's talk about constructors. During program execution, the compiler automatically allocates required memory for built-in data types, and after the program execution it deallocates the memory. The constructor method is used to allocate the required memory for the objects. I talked about the model or the class an object follows. So when we write the codes to construct a class, that doesn't mean whatever we are declaring inside the class, I mean methods and variables, they are being stored in computer's memory. Actually, that is a simple declaration to the compiler that we are going to have these properties inside this model or class. Until and unless we are not declaring any object of the class, those members don't get stored in computer's memory. And whenever we form an object of a class, a special method is used, and that method is called a constructor method. That constructor method automatically allocates memory space for the class properties, I mean variables and methods, and after program execution automatically those occupied memory spaces are released by the garbage collector of Java. The constructor method sets the default value for an object and allocates memory for that object. Now you see, inside a class, if we declare one integer variable, then whenever we'll form an object of that class, that integer variable will get a default value 0. But if we want, then we can initialize some other value also using a constructor method. Later we'll see this kind of examples. In Java runtime system, garbage collector deallocates the memory. Already I have mentioned that one. The objects in a program which are not being used since a long time are deallocated by the garbage collector. So in a program, whatever the objects we are using, if those objects are not being used for a long time in the program, then automatically the garbage collector of Java will be activated and it will deallocate the occupied memory of those objects which are not being used in the program. When an object contains the reference of any other object or non-object items like Windows font, file descriptor, etc., then the garbage collector cannot release the occupied memory of such objects, and a method named finalize method is used in Java to release the occupied memory. So it means we know the use of garbage collector, it deallocates the memory, but garbage collector is not capable of deallocating memory for all the objects, especially when an object is being used as the reference of any other object or some non-object items like Windows font, file descriptor, etc. In that case, garbage collector cannot deallocate their occupied memory space. In that case, what happens? Java has a special method called finalize method. That method is used to deallocate those things. So here you can see that a constructor in Java is a special method that is used to initialize objects. The constructor is called when an object of a class is created. It can be used to set initial values for the attributes. Here attributes means variables. Let's see one example. Say here the class name is my class. In this class we have a global variable x. Now this is the constructor. Actually constructor name and class name must be same. So we know that constructor is a method, and in case of a method we can give any name, but this is the speciality of a constructor, that it must have the same name as the class name. And some other differences are there between a constructor and a method. I'll discuss all those things later. So this is the constructor. What it is doing, it is initializing this variable x with a value 5. Now in the main method, what is happening? I'm forming one object. So class name space object name equals to new. Then this is the constructor. So this constructor is forming one object. Here the object name is my obj. And when this constructor will be activated to form this object, then the constructor body will be executed. And as it is written here x equals to 5, so x will get its initial value, that is 5. And after that, using my obj object, if we display the value of x, definitely it is going to display 5 as the value of x. So we are accessing this class member x, which is a variable, using a class object, that is my obj. And when this object is being formed, that time we are using the constructor, and this constructor is being executed. And as it is mentioned in the constructor body that whenever this constructor will be executed, x will get a value 5. Therefore, this constructor is storing 5 to the variable x. At the same time, it is forming this object my obj. Now using this object, if we display the value of x, it will display 5 as the output of this program. So in this example, probably one thing you have noticed, that the constructor method we have here, it is not taking any arguments here. That means this is a non-argumented or non-parameterized constructor. But it doesn't mean that a constructor cannot have any parameter. Let's see the next example. Here we'll see that a constructor is having some parameters. We have a class my class, and it is having one integer variable x, and it has the constructor here, and this constructor is taking one argument, that is one integer variable y. And what it is doing, it is just storing the value of y to x. So it is initializing x. Like in last example, we have seen that x was getting a value 5, so directly that time constructor was initializing x with a value 5. But here, whatever it is receiving in y, same value it is storing to x. So it is initializing x with the value of y. Now in the main method, what are we doing? We have formed one object, and this time in this constructor method we are passing this value 5 to it. So when this constructor will be activated, definitely my obj object will be formed, and as this constructor is taking one argument 5, so this argument will be stored to y, and the value of y will be stored to x. So ultimately 5 is going to be stored to x. After that, when you will display the value of x with the help of my obj object, like my obj.x this way, then the value of x, that is 5, will be displayed on the screen. I hope this is clear to you. So this kind of constructor is called parameterized constructor or argumented constructor. A constructor method can have many parameters. Let's see this example. Here we have one class car, and it has two global variables. One is integer variable model year, another is string type variable model name. And this is the constructor method of this class car, and it is having two arguments or two parameters. One is one integer variable year, another is one string type variable name. Then when this constructor method will be activated, it will store the value of year to model year variable and the value of this name variable to model name variable. This way this constructor method is initializing model year and model name, both the variables. Now in the main method, let's see what is happening. Here we are forming one object, and the object name is my car. So class name then object name equals to new, then the constructor name. And here, as this constructor is a parameterized constructor, so we are passing the value of the parameters when constructor is going to be used. So we are passing this year and this name to this constructor. So definitely this constructor will be called, and it will form the object with the name my car, and this year will be stored to this variable year, and this name will be stored to this variable name. So ultimately the value of year is going to be stored to model year, value of this name is going to be stored to model name. So model year is going to get this year and model name is going to get this name. After that, when we are displaying the value of model year and model name with the help of the object like mycar.modelYear and mycar.modelName, definitely this year and this name will be the output of this program. I hope this is clear to you. I told you that constructor method and normal method, they are different in nature. Now let's see some of the differences between a constructor method and a normal method in a class. First difference, constructor is used to initialize an object, whereas method is used to exhibit functionality of an object. So what does it mean? Already in the example you have seen that a constructor method can be used to initialize variables, like we initialized x with a value 5, or we initialized model year, model name with different values. So a constructor method can be used to initialize an object because variables are also objects. But in case of a normal method, what happens? A normal method is used to take certain actions related to that object. Means a method can be constructed to calculate simple interest. A method can be used to find out the number of vowels in a string. So this way normal methods can be used for different types of jobs, whereas constructor method is used to initialize an object. Second difference, constructors are invoked implicitly, whereas methods are invoked explicitly. So what is this? The examples of constructors we have seen, there we have seen that we are invoking the constructor during object formation. But probably you have noticed that many programs we write where we don't declare any constructor method. Then what is the secret of the execution of that type of program where we are not constructing any constructor? Actually, what happens if we are not constructing any constructor in a program, then Java compiler automatically forms the default constructor and it calls the default constructor for the execution of the program. Because until and unless whatever the class members we have, they are not being stored in computer's memory, the program cannot be executed. And when we form an object of a class, definitely using a constructor of that class we can form the object. So during object formation automatically the constructor is called. But in case of normal methods, what happens when we call a method, then only that comes into an action. If we don't call any method which is described in the class successfully, that method is not going to take any action in the program. So it is must for us to call a normal method, but it is not must for us to call a constructor method. That's why here it is said that constructors are invoked implicitly. That means automatically a constructor method is invoked, but a normal method is invoked explicitly, means actually forcefully we call that normal method to take its action in the program. Next difference is constructor does not return any value where the method may or may not return a value. We know that each and every method must have a return type. If the return type of a method is int, we can say that that method is going to return one integer value. If the method's return type is float, definitely this method is going to return one fractional value. So each and every method must have a return type. But in case of constructor, constructor has no return type. We know that when the return type of a method is void, that method doesn't return any value. That means what can we say? Can we say that a constructor's return type is void, that's why it is not returning any value? No, we can't say that. Actually, a constructor doesn't have any return type, not even void. So when we declare a constructor, we do not mention its return type. Even we don't write void as the return type of a constructor. Next difference is, in case constructor is not present, a default constructor is provided by Java compiler. In the case of a method, no default method is provided. So already I have talked about this one, that in each and every program we have to construct a constructor method. It's not true. If we don't construct any constructor method in a program, then what happens? Java compiler calls the default constructor for that program or for that class, and the program gets executed. Because if the object is not formed, then the class properties will not be stored in computer's memory, and if they are not being stored in computer's memory, the program will not be executed. So if we are not constructing any constructor, then Java compiler will call the default constructor, because for object formation constructor is must. So without having a constructor, objects of a class cannot be formed. So in that case, the default constructor will be called by the Java compiler automatically, and it will form an object of that class, and class members will be stored in computer's memory, and the program will be executed. The next difference, constructor should be of the same name as that of class. Method name should not be of the same name as that of a class. So already I have talked on this topic that the specialty of a constructor method is what? The class name and the constructor of that class, they have the same name. So it's not possible that a class, say the class name is a student, and I'm going to construct a constructor in that class, and the constructor name will be something different, say teacher. It's not possible. If the class name is student, definitely constructor name also will be student. If the class name is teacher, constructor name also will be teacher. So in case of other methods, we can use any name. If the class name is student, we may have a method there teacher, we may have a method there staff. But in case of the constructor method of a class, the class name and the constructor method name must be same. Now let's see here one example of constructor overloading. Already we are familiar with the term method overloading. Similar kind of concept we have here. In case of constructor overloading, what happens? Constructor overloading is a concept of having more than one constructor with a different parameters list in such a way so that each constructor performs a different task. For example, you see here we have a class, a demo, and as the class name is demo, whatever the constructors we are going to have in this class, all the constructor names will be demo only. So here you can see we have a default constructor because it is not receiving any argument or parameter, and this one is another constructor, but this is a parameterized constructor. Here it has a string type parameter s, and this is another parameterized constructor, but in this case it is having a parameter which is integer type parameter. So this way we may have multiple constructors in a program. So in a class we may have multiple constructors, therefore this is called constructor overloading. Let's see one example of constructor overloading. So here we have a class, and class name is box, and three global variables are there with height and depth. They are double type variables. Now inside this constructor, as the class name was box, so constructor name also will be box, and notice that here we don't have any return type because we don't declare any return type while declaring a constructor, and it is a parameterized constructor. It has three double type parameters, one is w, another is h, another is d. So what it is doing, it is storing the value of w to width, value of h to height, and value of d to depth. So this constructor is initializing these global variables with height and depth. Now another default constructor we have here, and what it is doing, it is initializing this width, height and depth with a value 0. So we can write width equals to 0 in next line, height equals to 0 in next line, depth equals to 0. Instead of writing in 3 lines, we can write this way also, as we are initializing with the same value. So width equals to height equals to depth equals to 0. Then another constructor we have here, it is also a parameterized constructor, but in this case what is happening, it is having only one parameter, that is one double type variable, len. So what it is doing, it is initializing in the same way like default constructor. It is initializing with height and depth, these three variables, with the value of len. That means if the value of len is 5, so width also will get 5, height also will get 5, depth also will get 5. Now we have a method volume, and this method is going to return one double type value, so its return type is double here, and what it is returning, it is calculating the volume of the object, and it is returning that, so it is multiplying with height and depth, and it is returning the product of width, height and depth. So all these things are happening inside this class box. Now we are forming another class, and this time the class name is test. In this class what we are going to have, we are going to have the main method here. Now you see we are forming different objects using constructors. First object name is mybox1, second object name is mybox2, third object name is mycube. So While forming this myBox1 object, we are using the first parameter is constructor, and we are passing the value 10, 20 and 15. While forming the second object myBox2, that time we are calling this default constructor. And while forming the third object myCube, that time we are calling the third constructor, that was also a parameterized constructor, but it had only one parameter. Then we are having a double type variable vol here. So what is going to happen here? Vol is going to get the calculated results of this method, volume method, and using myBox1 object, I'm just calling this volume method. So these values will be used for the calculation, and according to that the result will be returned to vol variable. And after that we are displaying the value of vol variable. And in second case, what is happening, using myBox2 object, I'm calling this volume method. So myBox2 object means the default constructor is being called. So in that case, definitely whatever the values the default constructor is storing, those values will be used for the calculation, and according to that the result will be returned, and then further we are displaying that result. And in this case, what is happening, the third object, that is myCube, using that object I'm calling this volume method. So you know that here the constructor is storing this value 7 to the variables, and those variables will be used for the calculation, and definitely this method is going to return the calculated result to vol variable, and that result will be displayed here. So this way, here we are using three different constructors. One is default constructor and two others are parameterized constructors. But the difference between these parameterized constructors, in first case it has three parameters, and in this case it has only one parameter. So this way it is working. I hope it is clear to you. Now let's see some practical examples. So I'm just going to open the codes of this class. Here the class name is student. We have three global variables. One is role, integer type variable, another is name, that is string type variable, another is marks, that is float type variable. And we have a default constructor here which is initializing this role, name and marks. So whenever this constructor will be invoked, it will store 101 to role, Rohit, this name to name variable, and 78.34 to this marks variable. And we have a method here, that is display method. It is just going to display the values of these variables, name, role and marks. Then what is happening in the main method, I have formed one object, and during the formation of the object I have called this default constructor. So obviously these values will be initialized, and after that when using the same object I am calling this display method. Display method will display the value of name, role and marks. So definitely these values only will be displayed. So let me compile this program. Okay, then I'm just executing the main method. Yeah, you see here name is Rohit, roll number is 101, marks is 78.34. So I hope this is clear to you. This way a constructor method works. Let's see another example. In this case the codes are something like this. Here the class name is student1, and we have three global variables, one integer type variable role, one string type variable name, one float type variable marks. Then we have a parameterized constructor here, and it has three parameters. One is one integer parameter r, another is one string type parameter n, and another is one float type parameter m. So what it is doing, it is initializing the variables role, name and marks with the value of r, n and m. So value of r will be stored to role, value of n will be stored to name, value of m will be stored to marks. Then we have the display method, and display method is going to display the values of these variables name, role and marks. Then in the main method what is happening, we are forming one object using the parameterized constructor, and as it is a parameterized constructor, so during invoking the constructor we have to pass the value of these parameters. So first parameter is integer type parameter, therefore we have passed this value 102, and second parameter is string type parameter, so we have passed this name Komal, and the third parameter is a float type parameter, so we have passed this value 76.28, And after that, using the object we have formed here, we are calling this a display method. So display method is going to display these values. That means 102 Komal and 76.28. Now let's compile this program. Okay, executing the main method. Yeah, you can see name is Komal, roll number is 102, marks is 76.28. So I hope this is clear to you. Let's see another example, that is our third class. Here what is happening, let's see. Here the class name is student2. Three global variables we have here. One is one integer variable roll, another is one string type variable name, another is one float type variable marks. Then we have a constructor here, that is a default constructor, because without any parameter we are constructing this, and some fixed values we are initializing. We are storing to these variables roll name and marks. Here roll is 101, name is say Rohit, marks is 78.34. So this default constructor will store these values to these variables. Now another parameter is constructor. I am going to form here, that is this one, and it is having three parameters. One is one integer type parameter r, another is one string type parameter n, another is one float type parameter m. Value of r will be stored to roll, value of n will be stored to name, and value of m will be stored to marks. Now we are going to have a normal method, that is display method, and it is going to display the values of these variables name, roll and marks. Now in the main method what is happening, we are forming two different objects. You see, in first case we are forming obj1 using the default constructor. So default constructor will store these values 101 Rohit and 78.34 to these variables. So definitely using the default constructor, when we are calling this display methods, at that time it will display 101 Rohit and 78.34. And in second case what we are doing, we are forming another object obj2, and in this case we are calling the parameterized constructor, and obviously we are passing the values of the parameters 107 Muskan and 79.27. so these values will be stored to the variables roll name and marks. So using this object, when we are calling display method, definitely display method is going to display 107 Muskan and 79.27. Let's compile this program. Yeah, it's okay. Let's run it. You see, in first case it is displaying Rohit, roll number is 101, marks is 78.34, and in second case, means in case of that parameterized constructor, it is displaying another name Muskan, another roll number 107, and another mark 79.27. So I hope methods and constructor, these two topics are clear to you, and method overloading, constructor overloading, all these we have discussed. So I try to give you a clear-cut concept. So in case any kind of difficulty, just let me know.